Okay, Biweekly contest 114. I was seeing friends this weekend, and so I missed the actual contest, so I'm doing this virtually. Wish me luck. I would love to start the virtual contest. Let's go. Okay. Ten seconds just for the problems to load. Just for this page to load. K-divisible components. Oh boy. Okay. I'm actually going to keep that open. Why not? Okay. The last element in the array. K equals 2. Okay. Sure. It's always... Come on. Come on. Well, I'm glad this isn't timed. Because this is really slow. Okay, so I can remove the last element, add to the collection. I assume it's always possible. Okay. So, the quickest way to do this is I need all the elements 1 to k. I could do the full 1 to k check, or I could just do a set. So I'm going to say elements collected equals set until elements. So the easiest thing would be to just keep adding things from the end of the list until I have all the numbers 1 to k. So that's going to mean that my elements collected contains k things. Okay, so Ellie equals nums.pop and elements collected.add Ellie unless Ellie greater than k. Okay, so basically the way this works is I'm going to add any number that's less than or equal. So here I would add 2, don't add 4, don't add 5, add 1. Oh, right, and I need the number of operations. Num operations equals 0. Okay. So, start at 0. Each time I pop something and add an operation, I put it into the set if it is k or lower. And so, because I'm working from the back, this basically just tells me how many steps it takes to hit everything k or lower. Should work. 4, 5, 4. Great. And now let's try it. Hey, okay. That was easy. Trickier. Make the array empty. Okay. So choose 2 elements with equal value and delete them, or choose 3 elements with equal values and delete them. Okay, so this seems pretty straightforward. Anything that has 2 values or that appears 2 times or 3 times I can obviously get rid of. But also if it's more, right? 4 is 2 plus 2, 5 is 2 plus 3, 6 is 2 plus 2 plus 2, or 3 plus 3. Basically anything that doesn't appear once is fine. Min number of operations required to make the array empty, or -1 if it's not possible. Okay, so first I need to figure out how frequent each element is. So count equals nums.tally. Okay. Total equals 0. Count.each do. I don't actually care about what element it is. I care only about the frequency. First. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9. Right, this has 9 elements, so they're doing 2, 2, 3, and 2. Sure. But this is just some element appears 4 times, they do 2 and 2. That's fine. Okay. Count.values each do frequency. Okay, so basically 2 options here. If something appears only once, like in the case of 1, then I want to return -1. Oh yeah, I need an if statement there. Oof. Okay, so if the frequency is not 1, then I'm doing this in the minimum number of operations. That means basically I'm taking out as many 3's as possible and as many 2's as necessary. I believe this would just be the frequency divided by the number of 3's, but rounded up. So total plus equals frequency over 3.0 dot ceiling. Right, because in this case with the 2's, I have 4 divided by 3, so that's going to be 1.333, which rounds up to 2. Because I can't do it in 1, I can do it in 2. Now I'm thinking about it almost as doing it 3 and 1, but the details don't really matter, because the point is it's possible to do by splitting it into 2 and 2, as long as there's not exactly 1 in the frequency. So yeah, this should work. I look at all my frequencies. Anything with a 1 is an automatic return. Without a 1, though, I just see how many times 3 goes into it rounded up, because I could be over by 1, in which case I do 2 2's instead of a 3, or I could be over by 2, in which case I do 1 2 instead of a 3. But that's still an operation. I guess this should be 4, -1. Let's do another test case just to be fun. Just for fun. So let's say I have 3, 3, 3, 3, 3, 3, 3, 3, 3. So this should be 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, shoot, I meant to do 7. Okay, so I have 7 3's, so this should be 2, 2, and 3, but it should return 3. Great. And there we go. Okay. So I'm given an array nums consisting of non-negative integers, subarray L less than or equal to R. Oh boy. Sum of squares is the minimum possible. Okay. Okay. Hmm. Oh. Interesting. Okay. So I want as many subarrays as possible that minimize the total score. Interesting. So the minimum score I would get from just doing and to everything, right? I believe that's the case. So num0. So min equals num0. 1, 2 nums dot length dot each. Min equals min and nums I. Yes, sorry, I'm just testing this. I want to see if I'm understanding this correctly. It should return 0 and 1. Great. And I could probably do and equals. Okay. So I can make everything and by splitting it like that. Alternately, really the only other options I can find where I hit a 0. Right, okay, so if I'm splitting into more than one subarray, and can't ever be less by having fewer elements, right? So if I can get 0 anywhere, then and overall will be 0. If I can't get 0 anywhere like this, then definitionally I can only do 1. Okay, so first of all, return 1 if min is greater than 0. Otherwise, I just need to figure out how many times I can split this to make it a 0. So what that's going to be is, if I'm just iterating through it, how many times do I get it to a 0? So I start at 1, that's not 0. 1 and 0 is 0. Great, start over. And. Okay, so I'm going to do this as a while loop. I equals 1. Okay, so min is 0 right now. Cur equals nums 0. Okay, so I'm going to say until I equals nums.length, cur and equals nums I, right? And now total sub r's, okay, there we go, equals 0. Sure. Current equals nums. If cur equals 0, okay, so I'm iterating through it. Nothing happens at 1, but I hit 0. That means that total plus equals 1. Total subbars plus equals 1, because that means I can split it here. Plus equals 1. it's also true that I plus equals 1 cur equals nums I. Okay. And I'm going to do I plus equals 1 again. Do I just return total sub-r's? I feel I might have a one off by 1 error, but I think this is actually fine. Because, okay, so like hypothetically, after this I could have a 3. You know what, I'm just going to test this first. Okay, so right now I could have a 3. So right now, this should hit it at 3, because it's going to get to it at 0, and at 2. Now this is going to return nil, but that's actually fine. I should actually do while I is less than nums.length, because otherwise I'm going to be comparing nil and nil, since I'm incrementing it twice. Okay, so this should get 3, 1, and it should get 3 again, right? Because with the 3 will be its own separate thing, but it doesn't itself form a valid array. Three, 1, 3. Now if this is 0, then it should actually be 4. Do I have any constraints? No, it could be 0. So that's actually a problem. So I'm just going to add 1. Total sub-r's. Hey, there's an insect here. Plus equals 1 if cur equals 0. Okay, yeah, that's covering just that case, because I could have a case here where I assign cur to be 0, but then I increment by 1 anyway, right? I could also just increment first, because I could just and it and itself. Sorry, I think I have a working solution, so I don't need to do this, but I think it's a little more elegant. And it might handle cases with zeros better. Yeah, that's a little nicer. Okay. So, like, worst case scenario, I'm cur equals nums I. Sure. So, I'm not doing the double loop each time. I'm anding itself each time. But that works better for the 0 case. And just to test this out with one more, so I do 0, 0, 0, 0, 0. This should be 5. Oh boy. That's no good. Right. Okay. Glad I thought of that. Let's see if this works. Okay, I'm gonna clean that up. I don't like that. Okay. Submitted. Great. So far, so good. What's my time? Let me look at people who have already finished because they're insane, so I can feel worse about my time, even though I think I'm doing reasonably well. You finished in only 10 minutes. I'm only twice as slow, except I have the last question. Oh boy. Okay. So all the nodes are distinct. Undirected tree of n nodes, 0 to n minus 1, integer n, edges of length n minus 1. Sure. Oh no. We want to node 3 are 8 and 4. Okay, I see. Uh-huh. Okay. So this would be really helpful if they were labeled by value instead of by index, but this is 8 and 4, that's divisible by 12. This is 1, 1, 4. Yeah. 1 plus 1 plus 4 is 6, so this is divisible by 6. Can't do any other split because you can't split 8 and 4, and neither one's divisible by 6. They need to be together. Sure. You couldn't leave it all as 1. Sum of values is divisible by k, so it could be 1. Oh boy. So 3. 0 is divisible by 3. 5, sure. 6 is unfortunately in 2, because otherwise 5 and 6 would work together. Right. Okay. Sure. Can't split these up. Oh man. I don't know how to even start this. Okay, I do understand the problem. That's a good first step. Where would I rank, by the way? Top 1%, assuming no one else finishes the problem. No, not quite 1%. Pretty close to 1%, assuming no one else finishes the problem. Okay, so basically what I want to do is I want to start at a node like, say, 4. Now, 4 by itself doesn't work. 4 plus 2 also doesn't work. And then I can check 4 plus 2, I either add 0 or I add 1 and 3. 0 turns out to work, so I know 4, 2, and 0 is fine, and then 1 and 3 itself is fine. So then 1 and 3 I see if I can split, and actually 0 I see if I can split too. Let's do it with this example. So this is easier if I start at a leaf than if I start at 0. So let's say I start at 6. So 6 is 1, 2 is 6, In this case, I have two options. 5 would work, but so would 0. So 5 by itself does not work, though. Right? 5 isn't valid. It's not a multiple of 3. 5, of course, meaning 2, but this node with the value of 2 is not a multiple of 3. So I have to include the 5 in 2 and 6. In that case, that does work. Okay. 0 itself works, great. 1 doesn't work, 1 and 3 doesn't work, 1, 3, and 4 does work. 1 and 4 also doesn't work. How do I operationalize this, though? Like, basically what I want is to find the sum of every subtree efficiently. Okay, so first of all, I need to turn these edges into an adjacency list. Turn edges into adjacency list. Find a leaf node. Iterate from leaf outwards. Outwards. And what I'm going to do from there is add nodes until I get multiple of k. Would there ever be a case when I would not? Okay, so if it is itself a multiple of k, I stop. If the node itself is a multiple of k, or really the way I think about it is I'm adding everything, and then I'm just taking off multiples of k from that, right? So from 6, I add 2, that's everything. Is 5 a multiple of k? No, and I can't go from it to 1. But this is a multiple of k, though. 0 gets a sum of k, so I take this off. Now 0 itself is a multiple of k, so then I go to 1. Okay. Remove subtrees that are multiples of k, basically. So it seems like DFS. Okay, I don't totally have the details for this worked out, but I feel I could probably get it in an hour. Let's find out. Okay, so the edges are pretty annoying. Connections equals hash dot new. Let's make this a set. HK equals set. And connections A dot add B. Connections B dot add A. Okay, and just to show what this looks like, sure. So node 0. Oh yeah, it wants me to turn an actual number. 7. Okay, no errors. I want it to work in all cases. Okay, so 0 is connected to 2. 2 is connected to 0, 1, and 4. Right. 1 is connected to 2 and 3, etc. 3 to 1, 4 to 2. Right? So these are showing the connections I want. Perfect, perfect, perfect. Okay, so I need to find the first one of those that is a leaf. And let's make this a class variable so I can do a proper DFS. Okay. Let's make values in K class variables too. Okay, and let's say now I do num subtrees. So here I need to find a node that is a leaf. So I'm going to do connections.each do node adjacents. So I just want to find something with exactly one adjacent node. So if adjacents dot size equals 1, leaf equals node, break. Guaranteed there will always be 1 because this is a tree. Num subtrees of node. Okay. Okay, so I need to get the sum coming from each node, iterating out from that one leaf, basically. Okay, so I also need a tree sum function. Sum from node of node memo equals array dot new, and this is going to be length of n starting at nil. So I'm just going to do sum from node of leaf. Okay. So total equals, so the node is the index value. So total is going to be values at node. Adjacents equals connections at node. So this is every adjacent node. And I'm going to say adjacents dot each do connecting node. Okay. So first of all, I want to make sure that my tree doesn't go backwards. So I want to say connections of connecting node dot delete node total plus equals sum from node of connecting node. And there should be memo of node equals total. Okay. So I'm going to ignore this for a minute. First, I want to see that this is working, so I'm just going to print my memo. And then I return 7, so there's no error. What? Right. Okay, so that's 18 from 0. That's not good. Like from 6, it should be 18 in this case. Oh boy. Okay. So first of all, what is my leaf? Because it shouldn't be 0 for either of these cases. Oh, it actually should be 0 for the first one. That's fine then. Okay, so this is 18. From 1, that's just going to be 1 and 3, so it should be 2. 18, 12, 17, 4, and 4. That's not great. So from 2, it should be 17. Which it is. Why am I getting 12 from 1? 3 and 4 are good. Oh yeah, no, that's 8 and 4. Okay, that's actually correct. I'm just dumb. What else is new? Okay, so from here, why is this printing memo but not printing leaf? It's not good. Let's go through it this way then. 0 won't, 1 won't, 2 won't, 3 will. So 3 should be the first thing it hits. So from 3 it should be everything. From 1 it should be 1 less than everything. Right, so 3 is maximum 18, 1 is 1 less. Perfect. Just to check, 4 should be doing its own thing. So 4 is just going to be 5, right? Yeah, okay. I don't know why it's not. This is annoying to check, but it is working. I'm correctly getting the sum from each thing, and it's memoized. So that's great. Why does that not work, though? Okay, this is totally irrelevant to me solving, but it's super annoying. Am I just blind? How did I have it written before? That's literally the same thing. Whatever. At this point, I think my eyes were just passing over 0 and 3 somehow. Or I had it blocked out or something. I don't know. Okay, I'm really confused why that wasn't working. It's making me feel a little crazy, but my code itself is working, so clearly I know how to do this. Okay. Num subtrees. So, first of all, if I get to a leaf node, then I return. So I'm only okay, so how do I want to do this? I want to check are the sums of all of the connections divisible by k? If so, great. Okay. Oh man, I know I'm super, super close. So 3 itself doesn't work. That's not divisible by k. 1 doesn't work. 0. Any single connection. So 3 will just be the connections of 1. 1 will be this is divisible by k. So is it just the number of connections divisible by k plus 1? Let's try that. That's super easy. No, that's definitely not it. So let's say total equals 1. And then for each thing divisible by k, I do the number of connections of that node. For each thing not divisible by k, I have to add it in, right? Because I can't include it by itself. 1. So I'm going to do adjacents equals connections node. So I want to write this out first, then I'll explain it more fully. I think I've got it. Let's see. So adjacents dot each do adjacent. So if sum from node of adjacent mod k equals 0, total plus equals num subtrees of adjacent. I'm going to see if this works. If it does, I'll explain it. So this should be 2 and 3. Well, dang. What? Memo. No! That's not good. What if I print my memo again? Divided by 6. Two things divisible by 6. Here I'm dividing by 3. I have 3 things divisible by 3. Oh man, that would be way too easy. I feel that would work though. Okay. First of all, I'm going to ignore that for a minute. I think I might have a really easy way to do this. Memo.count kv memo.values.count v. Oh man, this would be too easy. What? Oh yeah. Wrong function. Okay. I think this might actually work, which would be glorious. Oh yeah, memo is an array. That's a good point. Oh my god, please work. This would be amazing. Okay, great. So first, what I was doing here is basically I'm saying from each node, so I'm starting at 6. Now, 5 itself is not divisible by 3. And by 5, I mean 2. The value of the subtree starting at 5. The value of the subtree starting at 0 is divisible by 3, however, which means that this, 6, 2, and 5, is also going to be divisible by 3, right? If this is, so is the rest. So this gets me 1, right? So it's 1 plus the value here. Now I take the value at here. Here there's only one child because I've been eliminating them as I go. You can't go backwards. I turn this into a directed tree with a root of 6. So It turns out the subtree starting at 1, i.e. 1, 3, 4, is divisible by, has the sum of its values is divisible by 3, which means this has to be as well. I don't even technically have to check it. So then I can add 1 for the 0 and 1 for the subtree 3, 1, 4. And now this is just by itself. Now here's the really cool part. The really cool part here is that by definition, since these are just things, nodes iterating out from here, any subtree I hit, if it's divisible, I can add it. Right? 0 I can add, 1 I can add, and that means I can take the 1 out of 0 and add them both separately. So I can literally just count the number of things divisible by k. This leaf always will be. I think I do need a leaf, but it means I don't need to do this at all. I don't need to do this at all. I'm just basically arranging them, sum from leaf, and counting how many are divisible by 0. Amazing. Okay, that's a little nicer and refactored, and it works. Again, just talking through the process one more time because it's a little confusing. So first, I'm creating an adjacency list. Edges are kind of dumb like this. They're really helpful if I can key into one thing and get all the edges. Values and k. I don't actually need to make k a class variable. I do need values as a class variable, though, right? Yeah, because I'm doing sum from node. Okay. Start with a leaf of 0. I want to check if I actually need that. Yeah, I shouldn't need that because I am definitely setting it. But for some reason it doesn't like it, so fine, whatever. Set it at 0, typically overwrite it. Doesn't really matter. I could also go number 0 through 1 and iterate that way. The point is I find a leaf. So I make that leaf into the root and get a nice memo this way. Since that I don't even need this memo to be a memo in the proper sense, in that I'm never going to repeat, I'm always going down in the tree. But basically I want to find the sum going from each node to the rest of the subtree, again radiating out from the leaf that I set to be the root. Those are kind of opposite terms. Something with only one connection. It wouldn't even have to be something with one connection. No, yeah, it would. It definitely would because I don't want to have to include two possible things. The point is this is an extreme. So 0 would be a bad root. It would work in this specific case because it happens to split. But if it didn't split, like say, okay, none of these examples work for what I want. Well, actually they do. 2 itself doesn't work because 0 and 4. Okay, if it happened that neither 1 nor 2 worked, that 2, 1, 3, 0, and 4 were the things, then 1 would not be a workable root. So I want the root to like have this uniqueness criteria where there's only one way to split it, iterate going out from there, and that works best if the root only has one connection, basically. Okay, so yeah, so this just gets the number of things radiating out, and then anytime I get a count that's divisible by k, that means I have a subtree I can split off, so I should return those. Let's submit again for no reason. I'm officially done. Okay, how'd I do? I got no time penalty, so my rank here would be my actual rank. And dun 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 dun, a top 2%, 427. Yeah, that's top 2. Okay, That was the biweekly contest, 114. Too bad this wasn't a real contest. It was a pretty fun one. It looks like a lot of people had trouble solving this. Under 1,000, under 500 with more than half the time used. Q4 was a great question. This was fun. And that's it. And stop.